So we'll start off with fats. So we said fats are triglycerides that are solid at room temperature. An oil is also a triglyceride, but they are, or that are, liquid at room temp. And we've seen this all the time. Take olive oil, you put it, certain olive oil or higher fat content oils, you put them in to the fridge and they solidify. Coconut oil is another one of these ones where it's solid most of the time, but then if the moment you like put on your hand, it melts to a oil. And so we have two different types of fats. We have saturated and unsaturated. And so the difference is a saturated fat. So remember, all the fats have two main components. They have a carbon. They have a polar head group that looks like this, carbon with an OH and a double bond O, and then they have a big chain of CH2s that can go on for 16 or 18 or 20, and eventually they end with a CH3. Now this is what we call a saturated fat. And what that means is that all carbons have a maximum number of hydrogens attached. Well, how can we have an unsaturated fat? Well, that's a good example would be simply, so we still have this polar head group, and then we'll have some CH2, 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 CH2. At some point, we're going to have a CH, and we're going to have a double bond. Now this double bond is going to make things go at an angle, and we have CH, CH2, CH2, CH3. So there's kind of a kink. So this is the double bond. And what that means is I've actually have, if we look here, a CH and a CH, where I would have had a CH2 and a CH2. So I actually have a less hydrogens than I could have because I didn't finish writing this, the double bond. And so the reason why, and this is a unsaturated fat, unsaturated fat. The reason why unsaturated, no, it's not fat, we tend not to appreciate the unsaturated fats, or we try to steer clear from them because, saturated fats, because if we're going to draw this, and we're going to actually work more on drawing these line structures, but you can kind of look at it here. You can see how this part, we'll do it in a different color, this part of the molecule right here is very flat. And so you can imagine that we can stack multiple fats on top of one another kind of in a line where we have our polar head groups alternating and they can all stack. But if you look here, we have kind of this kink. So now we have our polar head groups. We can't have the same overlap. So you can see here that we only have this much overlap, where here we could pretty much have the whole thing. And so the more overlap we have, the more likely that is to be a solid. So saturated fats tend to be solid at lower temperatures, at higher temperatures, so like room temperature, than unsaturated fats, which tend to be liquids. And so to write that out, saturated fats tend to be solid at a higher temperature than unsaturated fats. Okay. And so, anyway, we can go past that. We could talk about trans fats and non-trans fats, and that's just where the double bond is, and really we don't have to get into that too much, but that's the difference between saturated fats and unsaturated fats. So the next we can look at carbohydrates. So carbohydrates, saturated fats, that's one. Carbohydrates. So we'll have three different kinds. We have simple sugars. So we can strip carbohydrates. So carbs can be one of three things. They can be monosaccharides, or simple sugars. Two main type of monosaccharides is glucose or fructose. So glucose or fructose. Make this a little smaller. Okay. And so this is what we call blood sugar. That's how we transfer most of our sugar in our blood, is with glucose, and fructose is fruit sugar. And so we'll get into the structure of those in just a sec. And we can take these building blocks, these monosaccharides, and we can make a disaccharide. So 2 saccharides. And so we have different flavors. We can have sucrose, we can have maltose, or we can have lactose. So we might have seen these terms before. So again, these are all coming from disaccharides. So sucrose is table sugar. And so we have lactose is milk sugar. And this maltose is coming from our kind of grain sugars. So like beer, we'll be talking about maltose a lot. So different places where these are coming from. And then we can combine those into polysaccharides. So this is disaccharides. And because we're running out of room, we'll do it down here. Polysaccharide would be the last. This is more than 2. And popular ones there, amylose is 1. Starches is another, and glycogen is a third. For polysaccharides, again, there is a lot more. And so there are a couple, so these are all different carbohydrates that our body can digest. There are a couple that we can't digest. So undigestible, carbs, so we can't do this. Cellulose. And so humans, do not have the enzymes to break down and obtain the glucose, which is what cellulose, so paper, is made out of. There is specifically a glucose linkage, so 2 glucoses together. It's called a beta beta linkage. And so the enzyme, this enzyme is called beta ligase. And the key thing here is that we actually, remember how we were talking about ethanol coming from corn, which was basically we're using the corn to get the glucose. Well, cellulose also contains glucose, so we can actually use the husk of corn, which has a lot of cellulose. We can use the corn for farming, for feed, but then we can use the cellulose husks, and we can actually add this enzyme. So add the enzyme, this beta ligase, or sometimes we use bacteria, but this enzyme tends to be what we use in a refinery, and we can get our glucose, which we can then ferment into ethanol, which is a biofuel that we can then use. So you can see that we can actually, cellulose for paper actually is made of sugar, which might be surprising for some of you. Was for me when I started teaching this class, like, oh. But if we had the enzymes, we could break it down. Some insects and some bacteria do, and that's where they can get their sugar from. So anyway, we do eat cellulose. It's a dietary fiber. It just helps with digestion, kind of like kale. Well, kale's got some. I'm kind of hate on kale, but kale's got some other things that are good. Okay, so then we have, if we look at a sugar, we can combine two different sugars. So what does a sugar look like? I'll post a link with a better one, but it's basically just a ring of carbons that are linked together. So we're going to make a little ring here with carbons. And then all we're going to do is we're going to have these lines that are going to be bonds to carbon, and they're going to be up or down. So we have 1, 2, 3, and so we have the OH is down, hydrogen's up, and we have OH up, hydrogen's down. You will not have to memorize this. This is just for illustrative purposes. I want to show you all the different glucose molecules. This is a alpha glucose, and really it's just looking at where the OH group is for each of these carbons. If you want to memorize lots of structures that look similar, take biochemistry, which you probably won't have to if you're in this class. And then fructose is a 4-carbon ring with an oxygen. So it's got a carbon comes out, and we got 2 carbons, and then on top we've got an oxygen, and then we have 1, 2, 3, 4. So we have a hydrogen. Here we have a CH2, OH, OH up top, OH down low, and then this is another CH2OH, and here we have an OH, and so this is beta fructose. Now what happens when we join these two together, we're going to take an OH from one and an H from the other. That's going to give us a water, and then the oxygen is going to link to the carbon, but it's going to link in a very up or down manner. And so depending on how we create this, we'll get, so we get sucrose plus water. That water's from here. And so that's how we can take sucrose as a disaccharide. So sucrose is a glucose and a fructose combined together. So we can get a lot of these different maltose, lactose. People who are lactose intolerant don't have the lactase enzyme needed to break that linkage between the two simple sugars. And so that's just something you have to take as an enzyme if you're going to have some milk. Okay. Next is proteins. So proteins, so we've done 2. Next big one is proteins. And so we're going to talk a lot more about proteins at the end of this, in the last unit. So all we can say is it takes proteins to make protein. So very rarely are we digesting the proteins that our body actually needs. So we need need to make specific proteins for cellular functions. And so we will either use the proteins for those building blocks, or we can use for source of energy. So if you ever watched Survivor, it was kind of big when I was growing up, where you put people on an island long enough without enough food, they start using their muscle mass as a form of energy if all of their fat burns through. So the next, we'll just leave it there. We're going to talk more about proteins in a little bit. The next one is vitamins, and I have a really cool infographic. Let's check that out on vitamins. So these are all organic compounds that have pretty cool structures, if you're into that kind of thing. So they're organic compounds. So let me give you one. I'm just going to draw a line structure to vitamin A. Again, we're going to be doing line structures here very soon. Vitamin A, retinol is what we can also call it, but vitamin A is what we seem to see a lot of. And so whenever you see chemists kind of on CSI Miami, or I don't know where else you see chemists trying to act smart, you see these structures, and so they are not terribly difficult to draw, but they look cool. So this would be a organic, and just so you know, plot twist, spoiler alert, these are just all carbons. So carbon, 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 and these are all hydrogens. Carbon. So anyway, so that's just what I mean by organic compounds. Is a hydrocarbon with some oxygens as well. So no energy can come from these vitamins. We don't digest them into something else. We just keep them as is. So often when you take lots of vitamins, if your body's not using them, most of the time we can digest them, though there are a couple different vitamins that we have to be very careful, because we don't actually, they get absorbed in fat, and then we can never get rid of them. So they actually are going to be toxic. So you have to be careful with those. So they are unchanged by, we don't digest them, so they're unchanged by digestion, which is really they're not being digested through the digestive process, might be a better way to put it. We cannot synthesize them from other building blocks, so cannot synthesize them in our body, so we have to get them outside. And a lot of times, the reason why they're essential is they're needed to act as coenzymes. Enzymes, we'll be talking about in a little bit, are proteins that help chemical reactions occur that normally wouldn't occur at room temperature or at body temperature. And so vitamins kind of act like this last little component that can lock everything together. So they are essential, they are unique, and so we know a couple of them, and I'll give you, there's an infographic posted in the notes today that you can check that out. And the last one is minerals. And these are just going to be our, think of mineral water is going to be like salts. So our group 1 ions, so if you look at the first row or column of the periodic table, and then we have others such as calcium, chloride, magnesium, and we have phosphorus. We actually get phosphate, PO43 minus, and sulfur, which we get in the form of SO42 minus. Minerals, those are different ions that we need that are used in different processes. Again, that we don't really use for energy, we just use as part of processes or building blocks for different things. So those are the 5 essential amino acids, or not amino acids, essential nutrients. that we talked about. So if we go all the way back up to here, sorry, right here, we have the 5 different types of classes of nutrients that we need. We can either use them for energy. So we can use them for energy right here, or we can use for building blocks to make what we need. So that is the end of the energy unit in terms of food, and then we're going to move on from there.